You know, finding the volumes for prisms really aren't that bad as long as we take it slowly and really think about geometrically what's going on. For example, if we start off with a rectangular prism, sort of looks like a box, right? Well, you can actually think about finding the volume by thinking that, well, the formula is just we take the length times the width times the height. Or another way of thinking about it is we sort of find the area of the base and we multiply that by the height. So either way of thinking about it will lead to the correct answer. What is the volume of this? Well, it's going to be 5 times 2, which is 10, times 3, which is 30. And so the answer is 30. And then what are my units? Well, they're centimeters, but now we've got volume. We've got length times width times height, so we have centimeters cubed. So the answer is 30 centimeters cubed. Okay, so that's not too bad. How about this one? Let's take a look at a very special rectangular prism, the cube. So the cube is a rectangular prism where all the sides have the same length. So let's find the volume of a cube with edge length equal to 5 centimeters. Well, how would you do that? Well, you could just think about the formula we just talked about, which reduces down to just side cubed, because it's length times width times height, but all those are the same as the side. And so here we see the volume of this cube, which you could sketch out here if you wanted to. 5, 5, 5. The volume would be 5 cubed, or 125. And what are the units? The units are centimeters, but it's volume, so cubed. So, not a big deal at all, not a big deal at all. Now, I'll show you a big deal. This was not a big deal. You want to see a big deal? I've got a big deal for you. Check this out. Let's find the volume of a right regular pentagonal prism with base edge length 10 meters and a height 4 meters and a height of 10 meters. Now, let me show you the picture of this, and then you're going to see what a big deal really is. Look at this picture. So notice that this is, in fact, a pentagonal prism, and it's a regular pentagonal prism because I start with a regular pentagon over here, and I've sort of dragged it, if you will. I've dragged it a length of 10 meters. Each side of the pentagon is 4 meters, and so we have this pentagonal prism. We're supposed to find the volume of it. Well, again, philosophically, it's easy to find the volume of it. Philosophically, it's not a problem because we can think about just finding the area of this pentagon and then multiplying it by the height. If I put it this way, it's the height. So that always works for any prism. We can just think about it as, well, find the area of the base. Okay, it doesn't look like the base, but let's pretend that's the base, and then multiply it by the height. So that's great. So that's a fine way of doing it. The problem is, how do you find the area of that pentagon? Well, this actually is a little bit of work. So I'm going to pull this off here to take a look at this, and then you're going to really appreciate the cube. So let's think about this. Well, the pentagon is really just made up of 5 congruent triangles. So let me draw them in for you. I'm going to take the center of this regular pentagon, and you can see all 5 of those triangles. They're beautiful. Now we happen to know that the interior angle of each of these angles for this regular pentagon is 108 degrees. And these lines that we draw here, we also know bisect those angles. And so half of 108 is 54 degrees. So in fact, this little angle right here is 54 degrees. Not to mess things up too much, I'm going to write 54 degrees and put a little line right there. That's that angle right there. Well, it still doesn't seem to help me in figuring out what the area of this triangle is. You see, if I can find the area of that triangle, I can just then multiply that answer by 5 to get the whole area of the base. So how do I do this? Well, the trick is to drop a perpendicular straight down. It's actually going to be a perpendicular bisector by the symmetry, because this side equals that side. This is an isosceles triangle. And so the area of that triangle is 1/2 base times height. Well, 1/2 base, that's 1/2 times 4. That's pretty easy. Here's the hard part. We've got to figure out the height. What is the height? Well, it's a little bit tricky because all I know is that this angle is 54 degrees, and I know that this little piece right here is half of 4, and therefore that's 2. So let me draw what I've got here. I've got a little right triangle where I know this is 54 degrees. I know this is 2, and I don't know this. Well, now I can use some trigonometry. And I can remember that the tangent of 54 degrees equals opposite over adjacent. So question mark over adjacent. And I can solve for question mark and see that question mark, if I multiply both sides by 2, is equal to 2 times tangent of 54 degrees. And so question mark is 2 times tangent 54 degrees. Phew! Okay, well, now that I know that, everything else is going to be easy. That was the hard part. So if you survive that, then we're in great shape. Because what's the area of the base? Well, the area of the base is going to be, how many triangles do I have? 1, 2, 3, 4, 5. So 5 times the area of each of these triangles, which is 1/2 the base, which is 4, times the height, which is exactly the question mark we just figured out, which is 2 tangent of 54 degrees. So that's the base, and then I have to multiply it by the height, which in this case is 10. So I've got to multiply the whole thing by 10. And so that is the total volume. And now we can simplify this a little bit. In fact, we can do a little bit of simplification here, and we see this is just a 4 tangent times the 5 is going to be a 20 tangent, and 20 times 10 is 200. So I see the volume is 200 times the tangent of 54 degrees. Now, that's the exact answer, but if you plug that into a calculator to see what the decimal equivalent would be, you'd see about 275.3. And what are the units? They're meters, but it's volume, so it's meters cubed. And so there you have it. So a very tricky question, but if we thought about it a little bit and brought together some of the trigonometry that we might remember, in fact, we can do it. But don't you really now miss the cube?